So this is our last section of the unit. Hooray! Which means our unit exam is next week.
How many points is it made?
I don't really do a point system. I do a weight system. So it's like 65% of your grade.
Oh,
Yeah. But all of your tests
so
combined.
That means I need to study.
That would be a wise idea to study. So we're going to finish 1.7 with 1.7b, talking about absolute value inequalities. We talked about the equations yesterday, so we'll finish off with talking about inequalities. What happens when I have an absolute value symbol within an inequality statement? Before we actually dive into some examples, I sort of want us to remember or recall certain ideas that we talked in the past that we'll incorporate with today's lesson. So recall, I think it was 2 lessons ago that we talked about compound inequalities. There are 2 types. They were the or compounds and the and compounds. Visually speaking, for the most part, or compounds look something like this. It says recall, yes. And generally speaking, and compounds look something like that. There are exceptions, of course, but for the most part, if you have an or compounds inequality, 9 out of 10 times, there will be 2 shades going away from each other. And if you have an and compound, 9 out of 10 times, it will be 1 shading in the middle between 2 numbers. Hopefully this is not new information. We recently did this, yes? Right. And then recall the idea behind an absolute value equation. We saw yesterday when you did your practice, hopefully, that equations of this format equaling some number, I don't know, b, this means numbers that are b units away from c. So if we could solve that, we can't because I didn't put any numbers, but if we could solve that, we can visualize this as here's c somewhere, and then the answers to this equation would be 2 numbers that are b units away. So I could literally translate x minus c, or the absolute value of x minus c equals b, as asking you a question. Hey, what 2 numbers are exactly b units away from c? Let's use numbers. I think it might be less confusing. So x minus 7 equals 2 literally translates to what 2 numbers are 2 units away from 7. And of course, we know that the answer are 5 and 9. Yes? So an equal sign, an absolute value equation, is very, very specific. I'm looking for 2 numbers that are exactly 2 units away. It can't be 1.9 units away. It can't be 1.999999 units away. It can't be 2.0000001 units away. It is very, very strict. It has to be exactly 2. Well, what inequalities do then, if I had an absolute value inequality, is it allows for some flexibility. It allows some wiggle room. So if I had something like absolute value of x minus 7 is, I don't know, less than 2, answer this question for me. By changing the equal sign from equals to a less than symbol, is my threshold of possible answers getting bigger or smaller? Is the threshold getting bigger from 2 or smaller? Let me phrase it this way. So the answer to this equation, absolute value of x minus 7 equals 2, was 5 and 9. Why is it 5 and 9? Well, we can visualize it. If 7's in the middle, of course, 5 and 9 are exactly 2 units away from 7. That is why the answers are 5 and 9. What I want to do is change that equal sign into an inequality, say less than 2. So here's 7 in the middle. We saw that 5 and 9 were exactly 2 units away. But by me changing the equal sign to a less than symbol here, you can sort of see how the answers 5 and 9 in the above number line, they are, you can sort of imagine them as like windows, or I think the proper math term is neighborhood. This neighborhood here is exactly size 2, right? Those length segments there are exactly 2 units long. By me changing the problem into a less than 2, what should happen to this threshold, or what should happen to the size of the neighborhood? It gets smaller, it shrinks. So instead of the neighborhood being of exactly size 2, that is a neighborhood of exactly size 2, my neighborhood is going to be smaller. It could be size 1.9. It could be size 1.8. It could be size 1.7. So can we sort of imagine that if this right here, these numbers, 5 and 9, are the neighborhoods of exactly size 2, by changing it to a less than 2, I need to pick every single number that's smaller than that neighborhood, right? That would be this number. 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 If I kept on highlighting all of the possible numbers, I eventually will get a solid shading. Gee, where have we seen this shading before? We saw this type of shading in the and compound inequality, right? We saw that shading in the and compound inequality. So what this logic says is, anytime you have an absolute value that's a less than symbol, all it is an and compound inequality in disguise. Now, those of us with great deductive reasoning can probably guess my next example. If I had absolute value of x minus 7 is greater than 2, I apologize for being boring. If these numbers here represent neighborhoods that are exactly size 2, and I change the symbol now to a greater than 2, what do we expect the size of the neighborhood to do? Get bigger. So instead of being exact, let's say for the number 5, that's exactly 2 units away, I could be bigger than 2 units away. I could be this number, 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 I could also be this number, this number, this number, this number, this number. If I was to highlight every single possible number, we get this solid line, which, to no surprise to anyone, because we know how to do process elimination, looks like an OR picture. So that's sort of like the big idea, the concept behind an absolute value inequalities. So the idea is, anytime you have an absolute value problem that does a less than symbol, those are and compound inequalities. If you have absolute value with a greater than symbol, those are or compound inequalities. Now, do you have to memorize this? No, because if we apply the definition, it sort of tells us what to do. Let's take a look at an example here. Suppose I ask you to solve absolute value of 3x minus 1 is less than 4. Again, let's pretend we didn't memorize the idea above. Oh no, I don't know how to do this. I forgot the list. I'm bad at memorizing. Well, all you have to do is do what you did with the solving equations. Normal rules of algebra won't apply with absolute values, so you break down the absolute values with the definition. According to the definition, what can an absolute value of 3x minus 1 give me? 3x minus 1 itself. It could give me itself, or it could give me the not inverse, but the opposite of itself. Inverse is a different math word. But regardless if it gives me itself or the opposite of itself, according to the problem, they're both less than 4. And then you go ahead and solve it normally. Add 1 to both sides. Divide out the 3. X is less than 5/3. Easy peasy. Let's solve the inequality on the right. Again, you can distribute the negative in, but I think most students like to divide out the negative 1. 3x minus 1. But you have to remember, when you divide by a negative, you flip the inequality. And then you just solve it like normal. Go ahead and add 1 to both sides. Divide out the 3. And then you're probably going, well, how does this help me? How do I know if this is an and problem if I didn't memorize the above list? Well, when it comes to writing down inequalities, it looks nicer if things were written from least to greatest. So do you see how between these two numbers, 5/3 and -1, -1 is obviously the smaller number. So I'm going to write the -1 part first. So what does this say? This says x is greater than -1, x is less than 5/3. Think about that. What type of numbers... Oops. Whoa, that's completely wrong. -1 should be on the left. What type of numbers are bigger than -1 and less than 5/3? Well, do you see how those are the numbers in the middle? Bigger than -1. Oh, so these numbers are bigger than -1. Less than 5/3. Oh, these numbers are less than 5/3. Do you see how they meet in the middle? So that tells you, hey, this is an and problem. This right here is my solution. So yeah, we could memorize, stuff less than number is and, stuff greater than number is or, but honestly, if you just flat out solve it, it will tell you what it is because the math will do it. What do I expect as a final answer though? If this was a quiz or a test, if I put this problem on here, what do I expect you guys to submit? All this work here does give you the intuition that, hey, it is an and compound inequality, but I want it to be written in a specific manner. Do you see here how the shading starts at -1 and ends at 5/3? So that's what you literally write. Starts at -1. You always use a less than symbol. My shading is in the middle. Less than symbol. It ends at 5/3. That is the way I want you to write your final answer. So if you have an and compound inequality, I want you to write it all squished up together as one. Are we okay with that? Just so that our notes are complete, let's do one or example. Let's pretend that we don't know it's an or example. Suppose I ask you to solve absolute value of, 2x plus 3, bless you, is greater than or equals to 5. Again, I'm going to play the role of the student that goes, oh my goodness, I forgot the rules. I don't know what to do. Well, just solve it like normal. Absolute value tells you to use the definition. The absolute value could equal itself, or it could equal the opposite of itself. And regardless of the options, they are going to be greater than or equal to 5. Solve it like normal. So let's solve the left inequality. You subtract the 3. Divide out the 2. You get x is greater than or equal to 1. To solve the right inequality, you can distribute the negative, or what I think most people like to do is divide out the negative. 2x plus 3. When you divide by negative, you flip the inequality. That's negative 5. Subtract the 3. That gives you negative 8. Divide up the 2. Gives you negative 4. Again, I like to write things from least to greatest, so negative 4 is smaller than a 1, so I'm going to write my answer with the negative 4 first. I'm going to write, and then the 1 goes second, and then I have to ask myself, is this an and situation, an or situation? So what I do is I visualize it. It says numbers that are less than 4. What type of numbers are less than 4? These numbers, right? It says numbers that are greater than 1. What numbers are greater than 1? These numbers. Do the shadings seem to be going away from each other or towards each other? That tells you it's an or problem. Since it's a less than or equals to, these guys would be solids. And then you shade this way. So that's how you tell. Question.
Are you going to take points if you don't shade in the circles?
Yes. The question was, am I going to deduct points if you guys don't shade in the circles? The answer is yes, because technically there is a difference between this and that. They are actually two different answers. The top one says you include negative 4 as your answer. The bottom one says no, negative 4 is not a part of your answer. So they are conceptually different. What do I expect you guys to present to me as a final answer? Well, remember, ORs are the easiest types because ORs, you just leave them separate with the word or in the middle. So that is what I would expect for full points. X is less than or equal to negative 4 or X is greater than or equal to 1. Questions on this example? So yes, you got two choices. You can memorize the rules. Absolute value of stuff less than the numbers and absolute value of stuff greater than a number is an or, which is not hard to memorize, but I find it a lot easier, especially if you're starting out, that if you just solve it like normal, the problem will tell you what it is. If you solve it and your answer seems to be convergent together, it's going to be an and, because that's how ands look. If you're solving a problem and it looks like the answers are going away from each other, it's going to be an or, because that's how ors look. All the rules, all the regulations of absolute value equations that we talked about yesterday still apply. You do not want to do this definition until the absolute value is by itself. So we're not going to solve this fully, because I think you guys get the idea. But if I have something like 2 absolute value of x minus 1 plus 3 is less than 2, you wouldn't want to do any definitions. I'm not going to split this guy apart until I isolate the absolute value. So you got to get rid of the plus 3. You got to get rid of the times 2. So just FYI. Don't apply the definition until this absolute value is by itself. You guys remember that, right? What about special cases? Yesterday we had like no solutions, all real numbers. What do special cases look like when it comes to absolute values? Well, recall that the idea of absolute value, it'll always give you a non-negative number. If you put in the positive number in, it gives you a positive number out. If you put a negative number in, it'll give you a positive number out. So this absolute value of anything will always be a non-negative number. So your two special cases are, what happens if I have a negative on the other side? Well, all you have to do is read the story or read the sentence. So if I have absolute value of stuff is bigger than or equal to a negative number, well, again, absolute value of stuff. What type of answers will absolute value of stuff always give you? Itself or the opposite of itself. But if you were to classify the numbers, the type of numbers, the absolute value of stuff here will always give you a non-negative number. 0, positive 1, positive 2, positive 3, so on and so forth. So if I had something like absolute value stuff is greater than or equal to negative, for example, absolute value of x minus 2 is greater than or equal to negative 4, the idea here is that this guy here will always be a positive number. Well, what does this sentence say? Always positive is greater than or equal to a negative 4. Is that true or false? True. This is going to be always true, which means any situation where you have absolute value stuff is greater than or equal to a negative number, you do not have to solve it. You're done. Stop. Because the answer is all real numbers. Conversely, if you had absolute value of stuff is less than a negative, right? This guy here, remember, absolute value of stuff will always be a non-negative number. 0, 1, 2, 3. So this says something that's never negative is smaller than negative. True or false? This is false. This is never true. This is bad. So if you ever get situations like this, you don't have to solve it. Stop. You're done. Because the answer is no solution. Right? So those are the two special cases. If you have absolute value of stuff being bigger than a negative number, or absolute value of stuff being less than a negative number, you don't have to do any extra work. It's always going to be no solution or all real numbers depending on the sentence. Now again, don't be too hasty about dismissing. You can only make a determination if the absolute value is by itself. So if I had something like this, 3 minus 2 absolute value of x plus 4 is less than negative 3, you can't automatically go, oh, wait, it's absolute value less than, it's no solution. You have to manipulate this problem until the absolute value bars are by themselves before you can make a determination. And if you were to do that, minus 3 minus 3, negative 2 absolute value x plus 4 is less than negative 6. Divide out the negative 2, you get absolute value of x plus 4 is greater than 3. Hey, guess what? It actually does have a solution. It's going to be an OR solution. So that's just the moral of the story of this example here is do not be quick to dismiss just because you see a negative on the other side. You can only conclude it once the absolute value bars are by themselves. Okay? So that is it. That is the completion of 1.7b. That is completion of Unit 1 with solving absolute value inequalities. It's just like solving equations. You just have to do a little bit of extra thinking. And the main idea is to get rid of absolute values, apply the definition.